Okay, I will start with question 1. So question 1 is a question on kinematics, and it tests you on your ability to interpret a VT graph. So for VT graph, if you are not so confident about interpreting graph, what I suggest you to do is that you should always label the point of interest. So what are points of interest? Mainly it is when the graph change shape. So if you look at this VT graph, there are actually 4 points of interest, and your first job is to actually match these points of interest to the context. So normally for me, if I have a questions that I have difficulty visualizing, I will always sketch it out. So when I read the context, I know that first the ball undergoes free fall from rest. So I know that it is falling, there's a ball falling. So I will first sketch something like, okay, I'm on a cliff and basically the ball falls from rest. And basically I will try to jot down as much information as possible as I go. And I would want to consolidate all the information on the diagram so that when I look at the rest of the question, I can refer to one place and I can find all the information. This is especially true, especially you find that sometimes when you go through questions, you realize that, how come when the teacher identified the data for me, I'm able to solve, but when I first look at the question, I don't even know how to start. That is because the information is too spread out. So one exam trick is that you should try to consolidate all this information on one place, at one place. And usually that place for me, my personal choice is where I can have a diagram. So down here, I know that it fall from rest, so at the beginning, V is 0. And whenever I jot down a piece of information on my diagram, I will have a habit of striking it out from the text, so that in case, let's say I am doing the rest of the question and I find that I'm stuck, I cannot solve it, I would need to find other clues. Then at one glance, I can quickly see that, what are some of the things in the question that I have not utilized. So first is the from rest. The other one is free fall. So once I know, I see free fall, I know that the gradient here is definitely equals to 10, right? And I would also jot down the direction, right? So here I have this, then I will draw the diagram like, okay, this guy is falling down. So you notice that my arrow, I draw it on the side, because this arrow actually represent motion and not the force. So for things like that, I will have certain convention that that I'm used to when I am doing my practices before the exam. So as I read on, I see that the ball will fall, then after that it will hit the ground. So I will draw the ground over here, and normally for ground I will shade it like that. Then I will know that, okay, there's a ball over here. So I know that before I move on, I will of course need to say that, okay, this is my A point, and this is just before impact, so this is B. And with this, I will know that, okay, right before impact, this is my impact velocity. So I know that, okay, this guy over here, the speed, the velocity is actually 12, and it is pointing down, right? This is right before impact. So I have done this. Then it says it bounces up. So I know that, okay, there will be a point whereby it bounces up. And when it bounces up, of course, the velocity vector, if you see over here, before impact it is down, after impact it is up. So I would expect positive and then negative, right? So I do not know what is the velocity, there's no information about it. But then it says it bounces up and it reaches a maximum height. So when I draw my maximum height, I will not assume that it goes to the original height, right? Because I do not know. So down here, I will just sketch it out and say that, okay, this is my maximum height, 0.80, and I've made use of this, right? Then I will also include that in my diagram. So what is height? So it means that it is between point C and point D, right? Because point D, this is my maximum height, right? How I know? Can you recall? How do I know this is my maximum height? Because at maximum height, your velocity is 0. So that's how I know, right? Once I know this, I know that, okay, this is 0.8. it must be traveling between point C and point D, right, after impact to the maximum height, right? So this point 8 refers to this area here, and I know that, okay, this area is now 0.80 meter. So you see, once I read this, basically I have all the information at one glance, right? And according to your paper, many of you are able to answer A and B. Okay, if you are those that couldn't get it correct, it means that you have not prepared properly for your exam. So for part A, I suggest you go back and look at your kinematics, if not forces notes. It is there, exact same question. For part B, to find the time when the ball hits the ground, you can take reference from here, right? So once you know that the gradient is 10, you know that this is 0, 0. You know that this is t, 12. So you can make use of this coordinate and this coordinate, and you can equate to this gradient, and you will be able to find the unknown t over here. So this I leave you to try it out. I'm not sure whether your teacher will give you the full answer key or not. Okay, so for my class, you are supposed to work it out yourself lah. Okay, I will be only focusing on the harder question. So for part C is actually a challenging question to most of you, because they are actually looking for not just displacement, but for a certain time instance. So what is this K? So I need to go and look at here, and I will be able to see that, oh, you see, I haven't made use of the information K. I didn't cancel it out, right? So actually this K is when the ball reaches here, and I want to find the displacement. So displacement is defined as your final position minus the initial position. So the initial position is actually this, right? This is my time equals to 0. This is your initial position, and K is your final position. So meaning that that particular question actually is asking you to find this. And since you already know that here is 0.8, basically what you need to do is you need to find this, right? If you are able to find this, the green arrow, and you subtract it by 0.8, you will be able to find this red arrow. Okay, so I need to ask myself, okay, this green arrow is from where to where? And you can see from this diagram, it is quite clear now. This green arrow is actually the distance traveled between point A and point B, right? So I can translate it here. This is my point A. This is my point B. And how do I get the value? Between A and B, right? So I go back to my graph. This is my A. This is my B. So the distance traveled between point A and point B will be given by this distance. So this red color area will be this green arrow, right? And at the beginning, I have already said that this particular purple area will be given by this blue arrow. So to find this red, it will be the red area minus the purple area, and that will give me the displacement between initial position and final position. Okay, so to answer this, it will be just your red area minus your purple area.